Hello student, today I want to discuss the discontinuity of a function. We will discuss the second question of quiz 3. So let's start. So what was the question? We have a function f from 0 to 2 to r, and that function is defined as f of x is equal to 1 when x belongs to 0 to 1 union 1 to 2 and 0 when x is equal to 1. So let's recall the definition of continuity. Of a function at a. So what is the definition? F is said to be continuous at x is equal to a if for every epsilon greater than 0 there exists delta greater than 0 such that fx minus fa is less than delta whenever x satisfies mod of x minus a less than delta. So now my claim is that fx is fx is discontinuous at x is equal to 1. So I will use the method of contradiction to prove my claim. So we will assume the opposite. Let's assume that fx is continuous at 1. So what does this say? This says that for every epsilon, if you recall the definition, I am just using the definition. For every epsilon, there exists delta greater than 0 such that fx, we want to check continuity at a. I mean, we have said that fx is continuous at a. So our a is 1. So this is minus f of a. F of 1. F of 1 is 0. So we can actually write 0 here. And then this is less than epsilon. whenever x satisfies x minus a is 1 less than delta. Now let's see, take epsilon. Since this is true for all epsilon, there exists a delta such that this condition is true. So let's take this delta to be equal to half. Then what will be this condition? Fx is less than half. For every epsilon there exists delta. For this epsilon equal to half, there exists a delta such that fx mod of fx is less than half whenever x satisfies x minus 1 less than delta. Let's denote by delta naught because we have already used delta. Let's denote by delta 0. This is the delta naught corresponding to epsilon is equal to half. So now consider the number y 1 plus delta naught by 2. See, this delta naught is greater than 0 because epsilon, for every epsilon greater than 0 we get a delta naught which is greater than 0. So remember this fact, delta naught is greater than 0. So delta naught by 2 is greater than 0. So now add 1 both to the both side. 1 plus delta naught by 2 is greater than 1. Okay, so of course then if you see 1 is equal to 1 and minus delta naught is less than 0 because delta naught is greater than 0, so minus delta naught is less than 0. So 1 minus delta naught is less than 1. Okay, so use this thing here. So this will give 1 minus delta naught. 1 is greater than 1 minus delta naught. So that fact I am using it here. Now to this equation 1 plus delta naught by 2, this equation you add delta naught by 2 to each side. Okay, then you will get 1 plus delta naught is greater than 1 plus delta naught by 2. Now use this fact, 1 plus delta naught is greater than 1 plus delta naught by 2. Here you will get 1 plus delta naught. So this thing y lies between 1 plus delta naught to 1 minus delta naught. Okay, so let's write that down. Y is between 1 minus delta naught to 1 plus delta naught. So y minus 1 is between, I am subtracting minus 1 from this delta naught to minus delta naught. So take mod is side and 1 minus 1, y minus 1 is less than delta naught. So y actually, this y actually satisfies this condition, y minus 1 is less than delta. So f of y, so this condition will also be true. Why? Because whenever there is some x such that x minus 1 mod of that is less than delta, this condition is true, fx mod of fx is less than epsilon. In our case we have chosen epsilon to be half and the delta is delta naught. So our y minus 1 is less than delta naught, I mean the mod of that. This condition is satisfied. So for this f of y, the mod of that is less than half. F of y is less than half. But what is y? Y is 1 plus delta naught is greater than 0. So this is y is greater than 1. Once this is greater than 1, the value that it takes is equal to 1, right? Because this is greater than 1. So f of y will be 1. Mod of 1 less than half. 1 is less than half. But half is less than 1, right? So this 1 is a contradiction to the fact that half is less than 1. So 1 and 2 contradict each other. So our assumption that f is what did I take? F is continuous at x is equal to 1 is wrong. So that means fx is discontinuous at x is equal to 1. So my claim that fx is discontinuous at x1 at x equal to 1 is proven. So that's it for today.